Hello, my friends. You're welcome to yet another edition of OS e-learning platform. And without wasting any time, allow us get into the topic of discussion: principal mathematics or physics, senior 5, senior 6. Why am I stroking it? Math or physics. It is actually relative velocity, a discipline that we cover in both subjects, so that is in physics and mathematics. So today's discussion is basically zeroing on crossing a river. Now, while crossing a river, there are three cases we consider. We look at a case where a person is to sail a boat to the other bank at a point that is directly opposite to him. And case 2, sailing the boat at uh, a certain relative velocity, but above all with the target of landing the opposite bank within the shortest time possible. And then the last case is when the target is to land on the other opposite bank at any point. So the three cases shall be exhausted within these tutorials, and for today we shall zero much on the first case where someone is to cross a river with the target of landing at a certain spot on the other bank, but on that spot the spot is actually directly opposite to him. How best, at what angle shall this person row the boat? And above all, what will be the relative velocity with which he is to sail the boat? Another thing, what will be the time taken for him to travel from one bank to another bank that's basically directly opposite to him? So today we shall look at case 1, whereby a person is from a point on the other bank and is to move directly opposite to him on the other opposite bank. So for him to move directly opposite to the other bank, he has to sail the boat. He has to sail a boat in a way that he has to set the course upstream. As per the illustration, let's look at the bank A, bank B. Now that the distance from A up to B, if it is given, that is the distance between the two parallel river banks. So the keyword here is parallel. These river banks are anticipated to be parallel for the case of numerical analysis. So if they are parallel, it means that the straight imaginary line joining the two banks should be perpendicular to these parallel banks. Now, taking that as our velocity of the boat in still water, we realize that he has to set the course upstream. Why do we need to set the course upstream? He has to set the course upstream for the fact that the water is flowing downstream. So in the due process, as he sails the boat, the flowing downstream water or the downstream flowing water will end him at point B. Just to show you something what I'm meaning, so the reason as why he has to sail the boat upstream is because taking a consideration where the water is flowing downstream. So as he sails his boat, this water pushes him, and in the due course he ends up moving along this very path. So within that time frame, he ends up or she ends up at spot B that is directly opposite to him. So that is the advice we should give to a person who wants to land on the other bank at a point that's directly opposite to him. So he has to sail with a course set upstream. Now, if v is the velocity of the boat in still water, what does it mean? It means that as it's setting his course at that very position, the angle between the imaginary direction, the imaginary line joining the two points on the either on the on the river banks. The imaginary line makes an angle with the velocity in still water, and I'm taking it to be theta. So as we are looking at that, we see that the water is flowing downstream and is also flowing with a velocity Vc. So throughout the process, we realize that for us to maneuver this very well, we need to get the resultant velocity with which the person sailing should use to move from point A to point B that's directly opposite to him on the other bank. So that V will be the resultant velocity or the relative velocity with which this young man has to sail. Okay. So now we need to resolve this component of the velocity in still water. So we realize that if I'm to complete this shape, I end up with a right angled triangle, whereby this angle it is opposite is this side, which is basically the direction of water current with that velocity, meaning this is velocity of the water current. So I have this as the velocity of velocity of the boat in still water. I have the angle, and I have this base. So velocity of the water in velocity of the boat in still water is taken as the hypotenuse. This resultant velocity is taken as the base, and this velocity of water current is taken as the height. So if you have such a right angled triangle, you realize that this component takes V, the product of the velocity of still water, velocity of the boat in still water, times the sine of the angle theta, because it is opposite to that. Then the side that is adjacent takes the cos. Because this angle is between the vertical and the velocity, the direction component, or the direction of the boat in the still water. So it is not with the base, it is not with the bank. If it was with the bank, we would have that as a different case. So this one instead, the velocity of still velocity of water current will be opposite to that angle. So that's why it will be resolved as Vs sine theta, and then V, which is the resultant velocity, will be resolved as Vs cos theta. So after realizing that, we now need to resolve the components of the velocity of the boat in still water. Check here, horizontally, Vc is equal to V sine, velocity of the boat in still water sine theta. We agreed on that one. Vertically, we realize that the resultant velocity will actually be also equal to the relative velocity, which is actually the velocity with which the man has to sail the boat such that he lands on the other point, that is on the other bank, and it is a point that is exactly directly opposite to him, and that will be a component of V sine cos theta. So the resultant velocity for crossing the river directly opposite will be equal to V sine Vs cos theta, and then the time taken to cross the river will be the total distance, that's from bank A to bank B, that total distance divided by the velocity, relative velocity, and that relative velocity we agreed to get it from resolving the component of direction of velocity of the boat in still water. And which component is that? We are taking the vertical component, which is Vs cos theta. So when I divide the result, I get the time taken. So those are equations that will be helping us to harmonize those numerical questions or items. So if you want to get the angle with which the bank makes with the velocity of the boat in still water, the direction of velocity of the boat in still water, That is basically getting the total 90 minus the angle with which the resultant velocity or the relative velocity makes with the velocity of the boat in still water. And now, playing with all this, we realize that you can get the angle with which the guy has to set the boat. You can also get most of the things that are required from this particular case on a condition that some are given. So you have to digest the scenario, you have to digest this task and get to know what to do. So basically that has been for the case 1, whereby one has to sail the boat upstream such that the direction of the water current sends him downstream, and with time he ends up sailing along the path AB and landing directly opposite to him on the other bank at a point B. So the keywords here are setting the course upstream, resolving the components, drawing the diagram correctly, and finding what is missing in the scenario. With those remarks, allow me end there. And if you found this tutorial a benefit to you, please go on by liking the video, sharing the video, commenting. Please, I would like to hear from you, your opinions, your contributions. I'm basically that. Then allow me send you to do one trial activity down there. I worked it out, the responses are in bracket, so you'll have to fight with them and also get the responses. Otherwise, thank you so much. Allow me wish you a nice moment. Bye bye.